Since the beginning of the current AI boom, every major model has shared the exact same bottleneck. It waits. It sits dormant until a human types a prompt, hits enter, and grants it permission to act. That requirement throttles output to the speed of human keystrokes. To bypass this, developers are redesigning systems to act without waiting for human input, allowing the machine to monitor and respond to events in the background. We now have concrete proof of this architectural shift. Anthropic, the company behind Claude, has been internally testing a new platform codenamed Conway. This internal leak reveals a system designed to move past the standard chat window model. Conway is a persistent agent. Instead of a temporary session that evaporates the moment you close your browser tab, it operates in a dedicated, always-on environment. It stays awake. An AI that runs continuously in the background destroys the traditional model of human-computer interaction. When the machine no longer needs a daily pilot, for every microtask, we have to isolate exactly what the human worker is supposed to contribute. Using Claude today involves opening a web page and asking a question. Conway operates through what Anthropic calls a Conway instance, a self-contained ongoing workspace where the AI lives independently of your immediate browsing session. The interface breaks out of the single chat bubble into a dashboard with three distinct areas: search, chat, and system. This structure gives the agent its own operational hub for managing resources and observing data. To function independently, the agent requires a sensory network to perceive the outside world. Conway achieves this through a built-in Webhook system, which allows the environment to monitor digital events across external platforms. These webhooks provide public URLs that outside services can call. When a customer database updates or a server logs an error, that signal wakes the agent up. The AI can then process the event and take corrective action without a human clicking a button. The system also includes a direct connection toggle for Google Chrome. This setting links your active web browsing directly into the agent's contextual loop, feeding it real-time information about your current digital environment. Linking a persistent environment with these external triggers results in an independent participant that reacts to digital reality as it happens. Recognizing an external event is only the start. Once a Conway instance is triggered into an active state, it needs the mechanical ability to actually execute the necessary work. Internal settings show Anthropic is building an extensions area utilizing a new file format, the .cnw zip package. This allows users to drop in custom tools, user interface tabs, and external APIs directly into the AI's core environment. These packages utilize context handlers to route information. If it requires pulling database metrics, running a cost calculation, and drafting a summary report, the agent can push data through those three specialized tools on its own. Historically, integrating AI required bridging your model to external software through complex third-party routing. Conway hosts its own native extension layer, making the agent adaptable to the workflow through an internal app store. Conway positions the AI as the central operating system that orchestrates others otherwhere through this native extension layer. If the machine can monitor triggers, route its own tasks, and execute software independently, the immediate question is, what role remains for the human worker? When the machine can monitor its own triggers, the human worker transitions from a technician providing manual inputs to a supervisor managing entire systems. The job shifts from executing individual tasks to orchestrating agents. AI systems are highly advanced optimization engines. They find the most efficient path to a specified goal, but they cannot decide which goal is worth pursuing. Defining the strategic intent, the specific why behind the work, remains a human responsibility. Next is the necessity of navigating real-world consequences safely. Autonomous systems require a human moral architecture to set boundaries. Only a human can evaluate the ethical trade-offs of a decision or manage the potential impact on other people. Finally, there is the requirement for creative vision. Conway will execute perfectly within the parameters it is given, but conceptualizing a novel service or finding a divergent solution requires envisioning a possibility that has no previous data for the AI to analyze. The shift to persistent, always on AI is not the obsolescence of the human worker. Instead, it is an elevation from mundane execution to essential strategic leadership.